Good day, I'm Craig Stewart. I'm CTO at SnapLogic. We're the provider of the leading intelligent integration platform. And what I'm going to talk about today is this debate around ETL and ELT. And the question today is, with the new environment that we work in, which better suits the business and enterprise today and making decision-making that much more effective. So let me just start. As you may tell, I'm a Brit, and actually we Brits do know something about analytics. We do have a little bit of a history there. You can see in the picture here, the picture of the Colossus at Bletchley Park, one of the great successes of the Second World War, where the great minds were brought together to actually crack the German Enigma ciphers, change the course of the war. Of course, that went on. Some of those same people went on to work at other companies like Lions, and the invention of the Leo, which was the electronic office, and that was brought into play to accelerate the capabilities of an enterprise, in this case, the Lions company, tea, cakes, very important. And this computer and the series of computers that the Leo actually delivered enabled a great deal more capabilities within the enterprise than had ever gone before. And of course, actually, this is where I started my career, SB721. That was the code for the printed paper, and I spent many happy hours carting those boxes around, printing off those things. And the people in the organization had printouts. Maybe they were monthly or even weekly or potentially even daily, but that was the frequency of analytics in those days. But this changed the world. This was one of those things, the invention of visicalc by Dan Bricklin and Bob Frankston, that actually you could start to put into the hands of your average user the ability to actually do calculations, to do them on a screen. I remember my brother bringing home this suitcase-sized device with a sort of 3-inch screen on it, and we were looking at this, and it's like, this stuff is really cool. And so this really changed what and who could use this technology for analytics. And then, of course, later we saw the evolution, starting with Excel in 1987, and that grew to the tool that we know today. But that was still in the hands of an individual user who was then manipulating those numbers, adding graphics, being able to have multiple sheets. And so there were some really great capabilities that were introduced. And still today, this is one of the biggest forms of analytics that goes on. And one of the interesting advances that happened was tools like Cognos PowerPlay came in, and they were not only giving you the ability to do this analytics, to do the querying on the data that you had on your local environment, but also going out to one of those databases where the data is being stored across multiple users. And this was a really important step forward. Again, another one of those paths that my career crossed. And I had worked for Cognos at some point. And this was really interesting. As I say, the data was held in these client-server type databases. And here's a few of the names. There are many more. There's the Informixes and various others that were in the mix. But they changed the accessibility of the data that people could use. And the database, the relational databases, became where an enterprise kept their operational data, and that same environment was used to query for their analytics. And that really gave those users the ability to understand what was going on with the data. They were able to make their own queries. The advent of SQL that enabled them to be able to manipulate that data. Data was held in a standardized rows and columns format, and that really enabled that move to the client server. Now, one of the interesting things that then happened was the evolution and the advent of the analytical database. And the analytical database started with things like Teradata, and that was a proprietary system. And then the likes of Netezza and Datalegro came along and started to use some commodity hardware in that environment, which then brought the cost of those things down significantly and made them available to a much wider group of people, much wider set of enterprises that could actually start to take advantage of this. And one of the ways that they did that was this separation of the processing from where the data is actually stored. And one of the things when you submit a query, a SQL query to one of these MPP databases, you're submitting it to essentially an orchestrator who then delegates the querying out to a number of different worker nodes where the data may be located. And so that accelerated the capability to be able to then aggregate it back together and give it back to the user. Really interesting and really changed the landscape of that, separating where the data was and the processing that went on it, and you could then add more nodes into the cluster and get a much greater capability. And that was great. And an evolution on from that, in Doug Cutting and the team pulling together this Hadoop thing with HDFS and the ability to actually distribute the data and to put an engine on top of it. But not only was it going to be running on essentially open source software, it was also running on commodity hardware, and that combination made it very attractive, so that you weren't beholden to some of the vendors like the Teradators in order to actually use the querying environment. And it was distributed and it was resilient. Unfortunately, it had some challenges of its own in terms of the stack that it was running on. And as we saw, it pushed a lot forward in its time. And it's still in use quite widely, but it also has been overtaken by some of the other things in the environment. And that's where the cloud data warehouses come in. And the cloud data warehouses, the likes of Redshift and Snowflake, have evolved to provide that query offloading capability where people can actually use compute on demand, essentially, to be able to query their data in the cloud. So rather than having to set up another server on premise to actually be able to process queries separate from their operational systems, you can now move that into the cloud. You don't have to make any capital investment in order to be able to do that. What you get is this capability to be able to load the data into a cloud resource, and you are paying essentially for consumptive usage. So what you actually use in the cloud is what you're going to pay for. And so these amongst the major vendors, we see here a list of these. There are others that are out there. the likes of Firebolt, which are emerging, some interesting technologies around those. But this gives you an idea of some of the capabilities that, or the technologies that have evolved. And one of the things that these guys did was, when you started with Redshift, for instance, you were essentially using another operational database or an analytical database in the cloud. But then they started, and I think it was Snowflake was actually the first one to do, was separating the storage, the underlying storage, from the compute engine. And what that then gave was the ability to scale both the storage and the compute. And being able to simply say, okay, well, let's increase the size of our compute capability rather than having to add additional sets of servers. This gave another interesting capability, particularly if you were, for instance, doing a large aggregation, sorts, etc. on your data, being able to simply scale your warehouse to do those tasks, and then you can scale it back again afterwards for the standard querying that might be going on. And that really changed some of the dynamics of what was really then possible. One of the interesting things that I think has happened subsequently, or perhaps in tandem with that, is the emergence of the analytical tools to be more visualization of the analytics that you hold in the data. And so we see that with the likes of Good Data and Tableau having emerged in the cloud environment. Certainly Good Data born in the cloud, and Tableau now firmly moved into that environment. And things like Power BI, again, really built to leverage the capabilities of the browser-based environments and being able to do the analytics and to actually satisfy the rich graphical analytics that people were looking for. And of course, what we have seen is some vertical integration happening here. And please do excuse the fact that I put ThoughtSpot on there with Snowflake. Each of these, Looker was acquired by Google. ThoughtSpot was invested in by Snowflake. Amazon has got their QuickSight, as Microsoft Azure with Power BI, really going the whole hog to try and get a really well-integrated stack that can leverage each of those layers to make it much more productive for the users. And when we then go on, we can see that there's all of those same questions that historically have existed on, what's the preferred way of storing the data so that it is most usable for the analytics. And these wars will go on. I'm in neither camp myself. The different ways of approaching the construction of your warehouse. I think one of the things that's really changed, of course, is that these things very much address the rear view mirror capabilities of analytics, the reporting of what's happened, rather than the looking forward of where the trends are going, and indeed the seeing round corners that the machine learning and those kind of capabilities actually can deliver on. But all of these things require the data to be in place so that you can actually do those kind of things. So some of the questions for what do you need to do? What do you need to have in place in this modern data architecture environment? Some of the things that are now different. How are you going to source the data? The applications are no longer purely the on-premise application. There's some on-premise, there's some in the cloud. You've got streams coming in, you've got the different velocities of data. when you've got that data, then how are you going to get it into your cloud data warehouse? And when you get it there, of course, the format that it's coming out of the source is not the same as the ideal format for doing the analysis in your data warehouse. And a really very important question is the cloud data warehouse the final destination of your data? And I think today, the answer to that is no. In most circumstances, the cloud data warehouse is one of the steps on the journey, and that is to deliver analytics, that is to deliver information to downstream applications. It's also to provide data services so that they can be queried by partners, internal and external, different systems. And in this data fabric, having the data products that come out of your analytics. It's not just purely analytics anymore. And so are you going to need some downstream capability of moving data, downstream ETL or reverse ETL as it's often being referred to now, and creating those services on that data, having the metadata, so you actually know, having a catalog, for instance, so that you can, your analytics users can actually understand where that data is and what's actually happening to it. So if we look at that in the context of the modern data architecture, there are a number of places in the environment that we need to actually deliver on this transformation capability. And that may be to use something like an ETL tool that does the extract from the sources, transform, and then load into the cloud data warehouse. It might be that you're in the camp of ELT, where you do the extract and load and transform actually in the cloud data warehouse itself. And we'll look at that, drill down into that in a little bit more detail. But in addition to those, as I said, it may be that you then need to deliver the data to downstream systems in some way. That's where the reverse ETL comes into. It may be that you need to create those data services, the APIs on the data, so that the data may be consumed by other users within the enterprise or outside the enterprise. And the analytics, the need for the metadata, the catalog, to understand where the data is, to be able to collaborate with other users on rating that data and understanding its meaning, etc. So there's a number of different places in this modern data architecture where the tools that are required in this environment are critical to deliver value. Now, we'll look at the ETL and ELT in a little bit more depth here. So this fundamental question, which has been going on for some time, of should you use an ETL tool or should you use an ELT tool? And in the order in which you transform and take these steps is the fundamental difference and where that actually takes place. So if we look at ETL in a little bit more depth, in the ETL world, you're extracting from those different source systems, whether they're databases, operational applications, streams of data coming in from a service bus or some message queuing system. Those get brought into an ETL server, and all the data flows through that ETL server, where the transformations take place and are then delivered downstream to the cloud data warehouse in the transformed form. So that makes it then ready for consumption by these downstream systems. Now, the ETL server needs to be beefy enough to be able to handle that. It needs to deal with the volumes of data, the variety of data, etc. All of that needs to go through that single engine. Now, in the ELT world, you tend to have a much more lightweight ELT server outside of that environment, which is coordinating the extraction of the data from those source systems and in getting that into the target cloud data warehouse, preferably with no impedance in the process, extracting from the sources in the fastest possible way and being able to get that loaded into the cloud data warehouse. That may be using something like BCP into a named pipe and straight into a loading utility on the cloud data warehouse. There are various different methods and various different capabilities that you'll want to put in place to actually get that to work. And that's what the more lightweight environment of the ELT server does, because it's going to delegate all of the actual transformation, the heavy lifting of the data, the manipulation of the data to that cloud data warehouse. And let's look at some of the pros and cons around this. So if you take the traditional choice of in inverted commas, there's the echoes, the benefit of the ETL capability is that this is proven. It's been around since the year dot, actually the CEO of my company way back when founded Informatica and built a really great business on that capability. You transform the data in flight between the extract and the load stage. Same tool across your whole environment, consistent metadata, and it's, as I said, proven. One of the disadvantages of this is you're not always dealing with data outside of the cloud data warehouse. Often the data has already got there, some other system has fed it, and you need to combine the data that's in the cloud data warehouse with this other incoming data. Well, now you have to extract it out of that cloud data warehouse to do the transformation, to then push it back. And that may not be very efficient. One of the most expensive things that you can do with bits of data is to actually physically move the bits. There is a real benefit if you can just get the data into place and then process it in that environment. The data gravity, as it's known, is a really important thing when you're looking at the efficiency of this system. Also, it may only be suited to traditional sources of data, the rows and columns type data. What about XML or JSON or some of the more modern formats of things like Avro and those kind of things? That might be much more complex to deal with. The traditional ETL tool may need to shred it into some pseudo-relational structure in order to actually then process it. It may not be the easiest thing in the world. And it may not be the most well-suited to the more modern forms of data and those 3 V's of data, volume, variety, velocity, etc. So it's one of the interesting things of it having been around for some time is, well, it's been around for some time and it may not be able to deal with the capabilities that are required for the modern environment. Now, looking at ELT, I call this the alt choice. It's an alternative, and you are utilizing the capabilities of the engine that you have available to you. These database engines have been built to do massive work on large data sets. And you'll see that actually, they're well suited doing huge sorts, joins, etc. The extract and load phases of this data movement can be very much optimized just to get the data between those 2 sources and not having to take it into that extra server in between and then extracting it downstream again. modern cloud data warehouses can scale on demand. So you can simply scale your environment as necessary to cope with the additional work that you may be putting on it and turning it back down again when you finish that. Much more difficult to do when you're dealing with an ETL server, which may need to be rather large to actually deal with that. Of course, on the downside, you are limited by the transformation capabilities of the data warehouse engine itself. So SQL type operations on the data, SQL functions. Now, of course, most of these systems have extensions. They have the ability to do store procedures or those kind of capabilities, extra data functions that you can write. They may not be as native as some of the capabilities the database has, but if you're dealing with that data, it can and it meets your needs, then actually it may be really very effective. Now, again, because it's focused on actually dealing with data in these cloud data warehouses, it may only really deal effectively with relational type data. The capabilities of handling the JSON and Avro and other formats of data, Parquet, for instance, may be more challenging, or the data engine may have some really good capabilities. Streaming may also be a limitation, but all of these different tools have different capabilities. One of the important things to look at is the costs. In that picture of the ELT, where we were dealing with that single central server that is actually doing the transformation, that may need to scale up really large. And there could be significant costs. Historically, there have been significant costs associated with that. Now, obviously, in today's world, you can do much more of that on demand, but all of that data has to go through that environment. And so those costs need to be borne in mind. It can be a very substantial cost. On the other side, on the ELT side, you're going to be paying for that processing inside your cloud data warehouse. So what you lose on the swings, you are gaining on the roundabouts. So in this case, you may be paying your cloud data warehouse vendor significant dollars for the time that you're actually processing that in the cloud. And you need an external process as well, because that's what's going to do the coordination of those things. And of course, whereas with ETL, you're transforming the data outside, in ELT, you're transforming it inside, and accessing data on the outside isn't something that is particularly dynamic. So you have to figure out, when you're looking at these things, where is the cost? What is going to suit best the environment that you find yourselves in? Now, the important thing is this is not the same question that we were asking 5 years ago or 10 years ago. The landscape has very much changed. The cloud and cloud data warehousing is a part of every enterprise, and it's involved there. Data warehouses are no longer on-premise, but some of the data still is. You have this hybrid environment in most enterprises where you need to be able to process on-premise, you need to be able to process the data in the cloud, bring them together to then deliver the value out of the other end. And the data warehouse infrastructure has evolved and continues to evolve. New capabilities being added every quarter by the big data warehouse vendors. Some really interesting capabilities being added, really improvements in the performance, improvements in the flows of data. And one of the things that is a particular bugbear of mine is that this last item, just be careful when you're choosing your tools that you're going to do this with, there's a number of tools out there that aren't graphical in how you're actually defining your transformations. One of the things about making that set of transformations available within the organization is it's important that you can visualize what's actually going on with the data. So that's some of the key things that are going on there. But there are some other things that we need to think about. And that is things that we learned over the years with the data warehousing. It is very useful to understand the data that you're dealing with. So doing data profiling. And where can you do that if you choose one tool or another? The cleansing, standardization, almost certainly you're going to want to do some manipulation of the data that's actually going to improve it. Aggregations, they can be done inside or outside, but you do need to figure out how you're going to do those. The denormalization, because the format that the data is in your source systems is not the same as the format of the data that you're going to need for analytics and downstream systems. Cataloging, so that you have visibility into what data is available, what can actually be done, and collaboration, so that your users can share the information, understand what's actually available, what may be there already that they're looking for, etc. So there's a really important set of things. So going back to that diagram of where these different tools fit in, things for you to think about along the way here are things like, if you're going to do ETL or ELT, where is that going to take place? Do you have to choose between the ETL or ELT, or could you do both? Could you just transform in your cloud data warehouse? Is there any need for any of the other bits around it? And do you need to be able to deliver that data downstream to other operational applications? Doing reverse ETL, as it's called. Do you need to make that data available as data services? And do your users need to collaborate on the data that you're working on in the form and make it discoverable through a data catalog? So there's a number of different technologies here that are important to have in your portfolio. And if we look at some of the technologies that we see out there today, there is the traditional ETL servers. There's the likes of the Informaticas and Talons, and I'm just mentioning a couple from each of these different segments. And these are by no means the be-all and end-all. There's also in the cloud data warehouse world the evolution of these loading technologies that provide as a service the ability to simply source the data, put it into a queryable schema in your cloud data warehouse, the likes of Fivetran and Stitch that have evolved, so that you don't actually need to build any of that ETL stuff. You just get the data, use these services to get the data into your cloud. Then there's the ELT servers, the people like DBT and Matillion. DBT tends to be more non-graphical. Matillion's much more graphical way of doing this, but offering users the ability to be able to do the transformations of the data that they want and to get that done within their cloud data warehouse environment. They may not do other things around it, and may not be focused on doing any of those things, but that's the area that they're operating in. And the reverse ETL space that we're seeing evolve, a bit like the Fivetrans and Stitches, where they're getting the data into the cloud data warehouse. The reverse ETL vendors like Hightouch and Census actually doing the reverse of that, taking data out of your cloud data warehouse where you've done your analytics and you want to actually feed that into your downstream application systems. And they are in the process of building out that capability to be able to do the inverse, to then take that data and deliver it downstream. And of course, there is the different services where customers want to put data services. So you may be using an API manager like Apigee or Kong to actually be able to expose some services that actually are reading that data and making that data available to downstream systems. So there's a lot of different technologies there. I would contend that SnapLogic actually delivers across all of those different segments, both getting the data in using the ETL format, being able to transform using the ELT within the database, the data services, the reverse ETL, the API management, the catalog, all of that actually being delivered in a single platform across the whole of the enterprise data landscape. So where we see in a modern data organization, streaming APIs, data coming in, being able to be pushed straight into processing applications, batching it through cloud file systems, doing ELT into the cloud data warehouse, delivering those downstream services. All of that can be done actually using a single tool, or as I've said, there are some really good pointed tools that actually deliver on some of those capabilities across the landscape. You have the choice of using a number of very specific tools, and you also could choose to use something like SnapLogic, which gives you a capability across your whole landscape. All right, hopefully you found that interesting. You see these different areas that we've put the technology in place to be able to actually do all of these things with different stuff in the environment. My name is Craig Stewart. I'm the CTO at SnapLogic. I thank you very much for your time today, listening to me. I hope to engage with you in the coming weeks and months. Thank you.